Hi, in this video we are going to solve question number 26 of GATE 2010 physics paper. The question is from complex analysis mathematical physics. The question is, for the complex function f of z is equal to exponential root of z minus exponential minus root of z upon sine root of z, which of the following statements is correct? So basically we have a function which is in the form fz is equal to exponential root z minus exponential minus root z upon sine of root z. We'll focus on removable and essential singularity. So function is said to have a removable singularity if limit z tending to z naught, where z naught is a pole, fz is some finite value. Okay, or there is another way. If the function fz is limit z tending to z naught fz is finite, then the fz is said to have a removable singularity at z naught. Similarly, there is another way. You just do the Laurent expansion of the function, and if for example if it takes sine z by root z, so if you do the Laurent expansion, you just expand it. So what you will get is a series, and there will be no negative term, no negative power of z in this series. There is no negative power. So basically that means that if there is no negative power in the expansion or power expansion of z, then sine z by z has removable singularity at z naught. So there are two ways through which you can find whether a function is said to have removable singularity or not. Similarly, essential singularity, suppose if you do some expansion of certain function, some function is there, and in that expansion you have no positive power but only negative power of z, then that function is said to have, for example in this case it is said to have has an essential singularity at z is equal to 0. Okay, now we will come back to this question. A question the function is fz is equal to exponential root z minus exponential minus root z upon sine of root z. Now in order to check whether it has a removable singularity at z is equal to 0, we just so limit z tending to 0, fz is 1 minus 1 upon 0, which is 0 by 0 form. So we'll apply L'Hopital's rule. So what we'll do is that we will differentiate both numerator and denominator, and then what we'll get is plus 1 by, because there is a negative sign in the exponential power, okay, divided by 1 by 2 root z cos of root z. This will cancel out. Now just put 0, so it will become 1 e to the power 0 plus e plus 1 by 2, sorry, because there is a 1 by 2 term. So I think I'm doing some mistake somewhere. Yeah, you just put 1 plus 1 divided by 1, so it will come out to be, because 1 by 2 root z is cancelling out everywhere, so e to the power 0, which is 1, plus e to the power minus 0, which is also 1, divided by cos of 0, which is 1, so it is 2. Now this is finite, and since this value is finite, we say that This function fz has removable singularity at z0. Okay, so option C is correct for this question. Thank you for watching this video.